Hi everyone, in this segment we are going to be discussing how we can approximate KEQ. KEQ is the equilibrium constant for an acid-base reaction. It is an approximation of the extent to which one side is favored over the other in the acid-base reaction. Now, some professors will want you to be able to approximate KEQ instead of legitimately calculating it with concentrations. Now, to approximate the KEQ for an acid-base reaction, we have to look at the acid-base reaction and find the acids on each side. That's the first step, okay? And then we're going to relate those pKa's to this equation pictured here. KEQ approximately is 10 raised to the exponent, which will be essentially subtracting the pKa of the product acid and the pKa of the reactant acid. Okay, pKa product acid minus the pKa of the reactant acid. Let's look at an example calculation for this example reaction. On the reactant side, we have pKa 9. On the product side, we have pKa 5. So our equation is 10 raised to the pKa of the product acid minus the pKa of the reactant acid. So we have 10 to the 5 minus 9, which is 10 to the negative 4, okay? And that basically is saying that that value is less than 1. If KEQ is less than 1, then the reactant side is favored at equilibrium, okay? And again, in our last video, we said you could just even look at the values and know straight up which side is favored. The side that's favored at equilibrium is the side with the higher pKa acid. Now, let's talk about KEQ and what that means in terms of values. So if KEQ is greater than 1, okay, that means you have 10 to a positive value, okay? If KEQ is greater than 1, then the reaction is product favored at equilibrium, okay? KEQ is 10 to a positive value, the reaction is product favored. If KEQ is equal to 1, well, then what's going to happen is you have equal amounts of reactant side species and product side species at equilibrium. In other words, KEQ equals 1 is 10 to the 0, right? If you had 9 and 9 on this side, then it would be 10 to the 9 minus 9, which is 10 to the 0, which is equal to 1. That would indicate that we are perfectly at equilibrium and there is no side that is favored. You have an equal amount of species on the reactant side and product side species. However, if KEQ is less than 1, okay, KEQ is less than 1, that means that we have KEQ being 10 to a negative value, a negative integer, which was the case here, and that would mean that the reaction is reactant favored. So we're going to say if KEQ is 10 to some positive integer, then we have a product favored acid-base reaction. If KEQ is 10 to the 0, which is equal to 1, then we are at equilibrium. There is no side that is favored. If KEQ is equal to 10 to a negative integer, a negative value, then the reaction is reactant favored. The reactant side is favored at equilibrium, okay? Now, why we might do this is we might want to figure out, is an acid-base reaction irreversible? And in general, if KEQ is 10 to a value of 3 or more, okay, then the reaction is irreversible. Okay, so essentially, if we consider these two species reacting together, when we react this way, the KEQ would be at least 10 to the 3, okay, right? It's 10 to the negative 4. If that value is 3 or greater, you can essentially consider that to be an irreversible acid-base reaction, meaning this would take off this hydrogen, forming these two species, and going back to this side is so infrequent or kind of inconsequential that we consider there to be an irreversible acid-base reaction. Yes, there still is some back and forth, but the concentration of these two species will be so large in comparison to these that we consider this particular acid-base reaction, NH3 deprotonating the carboxylic acid, to be irreversible, and we would form a vast predominance of our reactant side species. So be familiar with this idea of approximating KEQ and what that means in terms of product favoredness or reactant favoredness of a acid-base reaction.